Okay, we'll be doing a calculation from a previous paper of 2024 grade 12 final exam, where there is certain information given as a word sum, and then they ask you to calculate the resistance area, the stress, the strain, and Young's modulus. The formulas are given at the back of the question paper, so it's nothing that you have to study for from beforehand, but you will have to know when to apply which ones. Then, from the given information, it is always suggested that you write down everything point by point individually before you start with the calculations themselves, so that we can change all of these values to standard units, which is millimeters to meters. This one, it's also millimeters to meters, kilonewton to newton, and millimeter to meters. Okay, so the given question says a shaft with a diameter of 38 millimeters is extended. The change in length of the triangle before the L is change in length. So the shaft is extended by a length of 0.55 millimeters when a tensile load of 120 kilonewton is applied to it. The original length, the L, or original length, is 125 millimeters. Calculate these, the following: resistance area, stress, strain, and Young's modulus. Okay, so from the given information on the question paper, always start writing down the given values, the individual values down under each other, so that you can now go and change all of these values to standard units. So 38 millimeters, to change that to meters, you divide by 1,000. Currently, you cannot see where the decimal place is, but think about it in the following way. 38 millimeters is the same as saying 38.0 millimeters. Exactly the same thing. So your decimal place lies after the 8. So if you divide by 1,000, the decimal place goes 3 times to the left. So it will be 1, 2, and then another one to the left. So your value will be 0.038 meters. We are changing the value from millimeters to meters. The decimal place was after the 8. We divide by 1,000, so the decimal place goes 1, 2, 3 times to the left. The same with the following. The change in length is 0.55 millimeters. The decimal place will go 3 times to the left, so it's 0.00055 meters. Add the unit, the converted unit, after the value. The decimal place was before the first 5, and it goes 1, 2, 3 times to the left. Next, the tensile load is 120 kilonewton. Kilo means it has a value which is multiplied by 1,000. So if we convert this to standard units, it will be from 120 kilonewton to 120,000 newtons. Add the units after. We got rid of the K, the kilo, by adding 3 zeros. The last one is 125 millimeters. The decimal place is currently after the 5, which we cannot see, but it's very much the same as saying 125.0 millimeters. The decimal place lies after the 5. So you divide by 1,000, so the decimal place goes 1, 2, 3 times to the left, which is 0.125 meters. Okay, so now we've changed all of the given information to standard units. It's always safest to do this exercise first, and then to work from these values, which we substitute into the different formulas, which we will be doing after this. Okay, at this stage you haven't received any marks, but trust me, it really does help you or prevent you from making further mistakes with conversion of values. Okay, so now the first question is calculate the resistance area. Area, according to the formula page, the way that it's given to you at the back of your question paper is in this way: pi times diameter square divided by 4. But from experience, and I know that most of your other subjects that you have at school, for maths or science, or technical maths or technical science, you prefer to, or you are normally taught to rather use this formula for area, which is going to give you exactly the same answer. But be careful for the following reason. With this formula, which is given in the question paper at the back, it's pi times diameter squared divided by 4. So we're using the diameter, which is the given value. Most of the time in papers, the values are given in diameter. But if you make use of this formula, take note that diameter is not used. It's radius, which is half of the diameter. So we're going to do both of these exercises. You can choose which one to follow. But make sure if you use this way, this method, that you use the radius. So if you use the radius, the diameter, which is 0.038, you have to divide that by 2. 0.038 divided by 2 gives you, let's just first say over here, the radius is 0.019 meters. Remember, it's still in meters. We just changed it from diameter to radius. We did not convert anything. Okay, so we'll be using this value for this calculation and this value for this calculation. Choose whichever method you prefer. Okay, so firstly, if we do it this method, it will be area equals to pi times diameter squared divided by 4. So pi, you will be using that same value in your calculator, and then times 0.038 meters squared. Squared is outside of the brackets because it was still a meters value. We need to square this value, divided by 4, which will give us an answer. First type everything. Symbol for the square is the shift and then the pi value there at the bottom. So it's pi times 0.038 squared. We have to square this value of 0.038 divided by 4, which gives us an answer of 1.134114948 times 10 to the power of minus 3. Always add this exponential value at the end if it's given on your calculator. I prefer that we get rid of this, or at least that you know how to get rid of the times 10 to the power of minus 3. To do this, times 10 to the power of minus 3, we will, because it's negative 3, the decimal place has to go 3 times to the left. So it's going to be the same answer. Just remember over here, we were calculating meter squared value, so that's meter squared, and we'll just be getting rid of the exponential value over here. So if the decimal place has to go 3 times to the left, the answer will be 0.001134114948 meters squared. Now this answer, both of these, you can give your final answer in such a way, but most of the time you are taught only to give the answer, or to round the answer to 2 decimal places. It will be fine if you write this value in this, or the answer with 2 decimal places, but always try and use this original value, which is still in your calculator, if you use it to substitute and calculate something else in the next formula. So we'll be keeping in mind that this has to be typed in full as soon as we take the force divided by the area. Okay, let's quickly do it the other method. So if we do it, area equals to pi times radius squared, it will be pi times 0.019. And then we have to square this value. So pi times 0.019 squared gives us the same answer, 1.134114948 times 10 to the power of minus 3. Okay, so you see these two are the same answers. You can choose whichever method to follow, but make sure if you do it this way, you're using the radius. If you use it this way, you're using the given diameter. Okay, and again, make sure you first change the millimeters to meters, otherwise this final answer would not be correct. Okay, next we have to calculate the stress in megapascal. So it's not always expected that you write it down the final answer in megapascal. In this specific question paper, they were asking for you to give it in megapascal. So you will first be calculating the Pascal value of stress, and then afterwards you will be getting or converting that to megapascal. In your formula page, you will see to calculate stress, it's force divided by area. So the next step would be to substitute the given values into the formula. The given value for force, which is the load, was given as 120 kilonewtons, but remember we have to work with the standard units, so it's 120,000 newtons. So over here we write it down, 120,000 newtons divided by the area, which was this value, any of these two values here. So I'll just be writing over here 1 times 134114948 times 10 to the power of minus 3 meters squared. So at this stage you can see that the units are tending towards a value of a unit of newtons per, because it's divided newton per meter squared. And we have to know, since grade 10 already, we were taught that Newton per meter squared gives us Pascal. So the final answer for this value, after we've calculated it or typed it into our calculator, the units will be Pascal. So now we still have the original value of area in our calculator. And we are going to use this original value in this formula. So remember with the scientific calculators, it still has a memory of the last answer that you had. So without pressing the on button, the first thing that you type in will be the 120,000 newtons. So 120,000 divided by the answer, which was the original answer for the area, gives us a large value of 105,809,380.4 Pascal. So the answer here would be equals to 105,809,380.4 Pascal, because it was Newton per meter squared, which is a Pascal value. Okay, now we have to change the Pascal to megapascal. As a reference to remind yourself, kilo equals to 10 to the power of 3. Mega equals to 10 to the power of 6. Giga equals to 10 to the power of 9. And tera equals to 10 to the power of 12. So with this one, mega means it's the value of 10 to the power of 6. So we have to divide by 1,000,000 in order to change this to Pascal. So the decimal place will be going 6 times to the left. So it will be 1, 2, 3, 4, 5, 6 times to the left. So it will be 105 But because the last value over here where the decimal place is going to be, because it's a value of 8 after the decimal, that 8 will change the 5 to a 6, because we will only want to give the answer as megapascal, equals to 106 megapascal. Or if you still want to keep it as 2 decimal places with writing it still in megapascal, it will be 105.81 megapascal. Okay, so because the decimal place is going to be there, the 8 stays the 8, the 0 changes to a 1 because the value after that would be the 9. Okay, so either of these would be accepted, but in general, because in the beginning of the question paper, the instructions say that all final answers should be rounded to 2 decimal places, this would be the most commonly answered method. Okay, next we have to calculate the strain. Strain, the formula at the back of the question paper says that strain equals to the change in length divided by the length. Okay, so we are going to use change in length, which is this value 0.00055 meters, divided by the original length, which was 0.125 meters. Okay, if we type this into our calculator, 0.00055 divided by 0.125 equals to 4.4 times 10 to the power of minus 3. Okay, if we want to get rid of the times 10 to the power of minus 3, this we will, because it's multiplied by 10 to the power of minus 3, the negative means that the decimal place will be going 3 times to the left. So the answer would be 0.0044. A very important note to take over here is that there are no units. The reason for this is because in our formula we took a length of meters divided by a length of meters. So that means that the meters cancels out with the meters, which means that there are no units left behind. Unfortunately, it happens that if your value is correct over here, but any units is written down after it, that unfortunately means that your final answer will not count as a mark, even if your value was correct. Okay, so that's a very important note with calculating strain. It might also have happened that instead of using the converted value of meters divided by meters, you might have taken the value of 0.55 millimeters divided by 125 millimeters. So then the millimeters would still be cancelling out with millimeters. But do not ever change a value of millimeters divided by meters or meters divided by millimeters. Always make sure that the values of the two units over here, not the values, that the units for both of the numerator and denominator are the same. Then they cancel with each other, which means that the final answer would have no units. Okay. Finally, you are asked to calculate Young's modulus, which is stress divided by strain. So we will be using the answers of our previously calculated calculations over here. So stress divided by strain, we calculated stress over here, but you will not be using the value which was converted to megapascal. We still need to use standard units. So over here, we're not using megapascal, we are using the pascal value. So the Pascal value is the 105,809,380.4 Pascal, divided by the strain, which is the value with no units, which is 0.0044. Okay, then we'll be typing this into our calculator. So it is 105,809,380.4 Pascal divided by 0.0044, which gives us a quite large number of 2.404758,645 times 10 to the power of 10. So firstly, to check the units, it's Pascal divided by no units, so the answer stays in Pascal. Next, we would have to get rid of the, just want to check something here. Yes, we might have to convert this to another value, for example gigapascal, mega or kilopascal. But again, my suggestion is always that you should be able to know how to get rid of the exponential values over here. So if you were to get rid of this, it will be done in the following way. Because it says 10 times 10 to the power of 10, it means that the decimal place has to go 10 times to the right hand side. Remember, if it's positive, it goes to the right side. If it's negative, it goes to the left side. So currently the decimal place is over there. So now we have to move it 10 times to the right. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So after the 5, there has to be one more 0. So it would be in the following way. It will be 0, 5, 4, 6, 8, 5, 7, 4, 0, 2, 4. And the value is still Pascal. We did not convert any values. It stayed as Pascal. All that we did is we got rid of the exponential value, the 10 times 10 to the power of 10. Decimal place was between the 2 and the 4, and it went 10 times to the right hand side. So now if you were asked to change this to a standard notation over here again, if it were for say gigapascal, then your decimal place goes 9 times to the left. If it was megapascal, it goes 6 times to the left. Kilo goes 3 times to the left. Okay, lastly, just want to show you where the mark allocations are given. So firstly, for your formula application of calculating area, there would be 1 mark. And then also for your final answer, it would be 1 mark. Your final answer, which is in meters squared. Remember, you could have done it this way or this way. The same would be 1 mark there, 1 mark there. This gives us a total of 2 marks, either on the left or on the right side, whichever method you worked on. The next one would be a mark for 12,000 newtons, 1 for the correct substitution of the value which was calculated of the area over here, which is substituted correctly into the bottom value below the division sign. Then there would be 1 more mark given for megapascal, because that was one of the requirements, that you calculate stress in megapascal. Sometimes there's a mark given first for giving the answer in Pascal, but in this case it's only for megapascal. So here there would be 3 marks. Next, you have to calculate strain. So strain, both the values were given, either millimeters divided by millimeters or the converted values of meters divided by meters. So for the correct substitution, there's 1, 2 marks, 1 each per value, and then 1 for the final answer. Make sure again that your final answer for calculating strain has no units. Lastly, the question was that you calculate Young's modulus. So from the formula, Young's modulus is stress divided by strain. If you correctly substituted your value of stress, which is this one here, the original value of Pascal, remember, do not use the megapascal value, use the Pascal value. So over here, Pascal value correctly substituted, the strain unit, strain value correctly substituted with no units, there would be 1 mark. And then for your final answer with either of these two, you would get your final mark. So for this one also, there is 3 marks given. Calculation like this, but in that case then count 3, 4, 6, 3, 6, 9, 11 marks in total.